Shaw, Vice Chair for Child and Adolescent Psychology, and it is my honor and privilege to introduce today's speaker, Professor Elissa Epel, who works over at Laurel Heights, but with that whole group will be moving down to Mission Bay in a couple of years when the department's headquarters move down there. So Elissa attended undergraduate at a small private university on the peninsula that wears red, Stanford University. Worked with Phil Zimbardo there, among others. Went to the great clinical psychology graduate program at Yale, where she was advised by Kelly Brownell, and she was both in clinical and health psychology there. Without recapping biographically everything she's done, she's been a professor here in our psychiatry department for a number of years. When I first, as a little tyke, moved to Berkeley to become a member of the faculty, my next door neighbor was Professor Dick Lazarus, Dr. Stress. And it's really incredible to see where the field has gone over the last decades, led by people like Elissa, who've integrated appraisal, emotion, psychophysiology into the multifaceted construct of stress that we'll hear about much more today. Elissa has been a leader with Wendy Mendes and Eric Prather. She leads the NIH Stress Network. She's part of and a leader in a multi-campus research program at UC studying obesity. It's an obesity consortium with other UC campuses. She was elected to the National Academy of Medicine a couple of years ago, received several prestigious early career awards, most notably from the American Psychological Association and the Academy of Behavioral Medicine. That's the prestigious Neil Miller Award. Elissa's independent, she's collaborative. Her research spans basic work on stress all the way to what we'll hear some about today, applications to treating stress-related disorders. Last year, she co-authored with Liz Blackburn, The Telomere Effect, a notable book that's reached people in many languages in many countries with many practical guides for how to overcome the telomere deleterious effects of stress. So you'll hear her today, and I'm pleased to introduce Elissa Epel.
Thank you so much. It's so great to see so many colleagues here. And this was my anticipation and rumination about giving this talk was that that no one would be here. So thank you. And you're so far away. This will be my last ask, but I would love to actually see your face. This is like this auditorium really challenges my perception. Mel Hyman, Mel from GI, thank you so much for coming. If you come closer, I can actually see your emotional expressions as I shock you with information about stress. Okay, no one got up, by the way, for those of you watching remotely. So let me start. It's very fun to talk to my own colleagues here about stress, and what I did today is put together a picture of what our group is doing, kind of our health psychology group, our aging, metabolism, and emotions center that I lead with Eric, and our stress network, to really just put a framework together for you to just see where is the stress field, how can we measure stress better, and what do we know about how stress gets under the skin to promote accelerated aging. So I'm going to cover all that. But let's just start off with this quiz. So please try to think as accurately as possible. Even though you're only given 3 response options, this is an item used in a paper in Lancet, and assess your stress level for me. Try to be honest. Which bucket? Okay, so I'm going to tell you which responses are predictive of mortality. So this was measured in healthy women at 60, and then 10 years later, 4% died, and the question was, does their response to this predict mortality? So you can make your guess. And the answer is no, there was no response that predicted mortality. There's no relationship between stress and mortality. This is the best news. The news, being unhappy or stressed will not kill. We're done. Why am I even studying? You know, we're pretty much going to use our money for something else now. I like this one from Slate. This new data is solid proof that people who are depressed, anxious, or stressed need not worry that they're bringing down their own demise. This is a good public health message, so, you know, can't complain about that, right? So this is why I want to do closer, because this is actually interactive, so you're just going to have to yell out responses. But do you believe this conclusion, and why not? What do you think of this study? What if this study had 1 million people? 1 million people. Would you believe it more? That doesn't make it a better study, but that's why it got into Lancet. This was the 1 million women study. So I'm going to pick on Alexandra because I know she knows the right answer. Alexandra Croswell is a soon-to-be assistant professor here who runs our stress network and has done an amazing job over the last 4 years.
First of all, the response scale is terrible.
3-level response scale, extremely insensitive. So what else?
We don't believe it.
So there's a tremendous amount of data showing that different types of stress and distress are related to poor health, behaviors, poor health, and earlier mortality. So it's, of course, goes in the face of other data. Turns out this item and the unhappiness item are related to mortality. It's just that once you control for SES and health behaviors, you can wipe it out and say, look, there's no direct effect. I'm not sure what they were thinking would be left once you account for all the pathways we could measure. So let me give you a more complex model. Okay, so this is what you find in textbooks. This is stress. Stress is stimulus, so some event that threatens us, usually, survival is the prototype. Then we actually make meaning of that as I'm at threat, so there's our appraisal, and then we have a response in the brain and the body. So, and then today, of course, rather than physical threats to our survival, we do have those, but we have even more so the chronic psychological threat of psychological stress. So that's beautiful, isn't it? It's so complex. I'm done. Really, I'm done. No, I promised that we would show a complex model of stress, so I'm going to get there very soon and give you the bottom line here. So this is the linear view of stress, and it will never go away, but it works only in the moment when you're studying a really specific stimuli. But it does not ever explain how stress impacts health throughout the lifespan or throughout time, any chunk of time. It is just such a complex process. So, there's these different components of stress we talked about, and really, of course, what we like to say is stress is something that depends on who you ask. I can predict your answer for a room of psychiatrists and psychologists. It's physiological, it's in the brain, it's in the body, so that's what a neuroscientist or psychophysiologist would say. It's cognitive or emotional. Psychologists love perceived stress. It's between people. Wendy Mendez studies stress contagion and shows that you transmit it in non-conscious, non-verbal ways. And of course, the most common way it's measured is in the external environment, events, exposures. So most of the studies, population-based studies, are measuring divorce, unemployment. This is the land of, social demography and economists. So that's what stress is to these different people. And I think we really want to think of stress as the ever-changing environment that we live in. There are different, if we think of waves, there are different frequencies, different sizes, and then the question is, how is a person responding to the wave? Are they surfing? Are they under the wave? How well can they swim? And of course, there are different sizes of waves. So every once in a while, you will or have received one of the tidal waves of life. So let's just break this down into different types of stress. So there's traumatic stress, chronic stressors that go on, and daily stressors that we all experience. Now, what do we really know from the stress field so far? We have a sledgehammer effect from traumatic stress, particularly if it's during childhood. So, but we really don't, and so that is really on the map in a big way. And we you hope that there's a body of research that is so compelling that it's taken seriously by public health, by policymakers, by clinicians. And that's where we've become. In the ACEs field, in the early childhood adversity, we now know that in a dose-response fashion, early adversity is associated with poor mental health, poor physical health, or early mortality. So this is a huge focus of NIMH, but also National Institute of Aging, because it turns out this is such a big predictor of why we get sick early and why we die early. So we're really trying to understand how to reverse the effects of early trauma. That's the focus of Steffi Mayer, who is another postdoc here. So we want to understand how stress plays out in health and population health, but that means we need to measure it better. We need a common language. Precision medicine requires precision in medicine, in measurement. So how do we get there? So I'll talk about conceptualizations of stress, what we've learned from our caregiver studies, and then briefly new views of interventions that really specifically target stress processes. So rather than a linear model of stress, the opposite is really an emergent model of stress, where stress is distributed between self, others, and the environment in a cognitive, emotional ecosystem. And so if we can remember that, we will remember that stress is not a noun. We can never make a conclusion stress is related to this or that, because it's not one thing, it's multi-level. It's a dynamic process. So here is the conclusion of my talk. I'm going to give it to you at the beginning. This is a more multi-level lifespan model of stress that my colleagues and I have put together, Alexandra, Steffi Mayer, Eric Prather, George Slavich, Eli Putterman, and Wendy Mendez. So let me just point out a few things from this model. It is ugly. No one wants a complex model, right? It's hard to put all that in one study. So rather than that kind of linear stage model of stress, what we are pointing out here that's different is that people at any moment in someone's life, when you study them and you think you're looking at baseline, there is no baseline. What you're looking at is all of those blue boxes, which is their life experience, their life history, which has patterned how they view any event going forward in the moment. So context, early trauma is something we forget about. In the middle box, I have cumulative stress, which is what's happening in their life and their past exposure. And these serve as moderators of how people respond to stress in the moment. So we can't forget those. Those are often important also in treatment. In our meditation intervention studies, we find that people with early adversity respond differently. They actually respond even more than people without early adversity. So in the middle, we have, the way we live our life, the unit of our life is a day. We think of things in terms of a day. How was your day? And so if we take a really close look at how stress unfolds in a day, and we look at how people wake up to how they go to bed and what happened and how they respond to it, we can learn a tremendous amount of rich material. This is a really important edge in the stress field, is measuring daily stress. So in a way, we've kind of shined a light on acute stress as it unfolds in the moment or over a day. And so in that box, it's a small writing, so I'll just read it to you. We have these processes, psychological processes. When an event happens, we appraise it. We have non-conscious or unconscious processes that affect how we respond to it that we can't get from self-report measures. We have affective, emotional responses to a specific stimuli, as well as, of course, what next? When people have a lot of negative affect, they're going to cope with it and regulate emotion in different ways. And those ways may perseverate the emotion, it may re-stimulate it and make it recurrent and chronic, or they might cope effectively and have quick recovery. And so these of course trigger multi-system stress responses. We call this allostasis. These are the intertwined regulatory processes in our body. Of course, the neuroendocrine system, the immune system. These are biological responses that are associated with the psychological responses loosely. So they are not the same thing, and we need to measure both if you want to know what's happening in the body. Wendy Mendez has shown that more than anyone. So in the middle of this bright yellow sunny day, are the stress processes that we think make an event live on and on in the mind. This is the substance of chronic stress. And these are the perseverative thought processes that keep stress alive. So anticipation before something happens. There's, of course, a response and a recovery, and then there's rumination after it happens. And so we can measure those, and of course there's habituation over days of how much someone gets used to a stress. These influence our, of course, our stress exposures influence our brain architecture and how we perceive and respond to stress in the future. So it's a recursive process. And at the very end, that black box is biological aging and eventually onset of disease. So we've been, at the Aging, Metabolism, Emotion Center, we've been really focused on biomarkers of cellular aging, because we get the rate of someone's body's aging decades before they develop disease. So it's a window into a biological wear and tear process where we don't have to wait till people develop frank disease, which is, of course, changes everything and is a confound. So here's our stress network. We have had, besides people I mentioned, we've had Nico Da Paz and Steffi Mayer from Germany join the network as postdocs. And one of our tasks, I mean, in all honesty, it's been really quite challenging to think that we can take the stress measurement field and do better than what people have done over the past 50 years. And, you know, how can we actually bring new models and measurement to this field which measures perceived stress, life events, and you know that's pretty much where it's been. And now we can measure stress in the moment with EMA. So our first task was really realizing that there's no good crosstalk between disciplines, and that we're all talking about something different. So we've developed a stress topology. You can download this at our Stress Center website. And the point of the topology is really just what are the core elements of stress measures that we can harmonize across disciplines. We can point out and say, don't just say stress is related to depression or not. Tell us what you're measuring in a way that we all understand, whether you're a population health scientist or a neuroscientist. So this is exactly what we've done. So step one was really, this sounds so basic, but if you look at any paper, and I'm guilty of this too, particularly in old papers, we talk about stress as if it's a thing we can make conclusions about, rather than the very first step is talking about a stressor and a stress response. And I know that seems basic, but it's just not done. So that's step one. So we've described what are the dimensions of exposures and responses that are important, that we should be cataloging for editors, for reviewers, and of course when we write a paper, to be defining what we mean when we say stress. So of course time scale is important. Acute stress, daily events, life events, and then chronic stressors, including traumatic stressors. These are different time scales. They overlap, they're interconnected, and by measuring these different ways that people are exposed to stress at any point in their life, we can get a better picture. Of course, the period in life matters. In utero and early childhood stress has a bigger effect on biological embedding. What Nikki Bush studies, Tom Boyce, we have studies on pregnancy trying to understand how maternal stress influences. Of course, biomarkers in the offspring, but what's so interesting is we find, for example, more events exposure during pregnancy predicts shorter telomeres in cord blood on day one of life. So things start early. When you're measuring cellular aging, things start in utero. In terms of stressor attributes, of course, duration, severity, controllability, and then thinking about what are the aspects of this type of event that may cause the type of toxic stress that we care about. And so the bottom line here is not all stressful events are equal at all. Interpersonal stressors get under the skin more. We are social mammals. So let me show you an example of that. This is a large study of people with depression looking at what events happened to them in the year preceding their depression. So you can see losses and separations have been measured, and they do predict greater odds ratios of developing depression, loss, death, if you broke up with your partner or spouse. Now, what if your spouse broke up with you? Is that going to be the same odds ratio? That is a targeted rejection. That is a type of stressor that's a threat to the social self. And you can see that was a 22, the odds ratio explodes when it's that type of event. So we need to think of the type of event and how that's affecting psychological stress process. So when we think of response, oh, this is a pretty juicy category. Of course, there's global perceived stress, right? You always have to have that in your grant. You put it in your study. It's short, but it's never going to predict much. It's always going to be a small effect. It is picking up personality, random things that happened over the last month, as well as psychological perceptions of stress. So we want to get more specific and look at how someone's responding to a specific event. So then there's subjective response to specific events. And then if you're looking at a specific event, then you can really dig in. And you can look at motivational states. So like what Wendy does in her psychophysiology lab is gets to look at the process as it unfolds. So what we've been doing is on a daily basis is by measuring people in the morning and every night for a month of their life, trying to look at these different aspects of how they're responding to the biggest stressors in their life. So appraisals, emotional responses, coping behaviors, emotion regulation, and then what we put last here, but we think is critical, perseverative thought processes. This is what keeps stress alive in the body, increases the kind of allostatic state of vigilance in the autonomic nervous system, and of course is related to depression. So we hope it will provide a common language, it will help people develop multi-level models, and really make people understand that stress is a lifespan unfolding process. So, any questions before I move on to caregiving? Okay, we have been studying caregivers. They're a prototype of chronic stress. They take care of someone else 24/7. They typically have low self-care behaviors. So it usually goes on for years. We've studied caregivers of people with dementia and of parents of children with autism. So what is that like? You will be or have close caregivers in your life. So this is something that happens to many people. Of course, parenting is caregiving, and that is what we've been studying. But if you're parenting a child with excessive special needs, we really are finding that's different, as you'll see. So is it a marathon or is it a sprint? So we've been talking about chronic stress as a context, but when you look on a daily basis, you can see how it unfolds. So an event has an onset and an offset, and you can look at recovery, like bereavement. But with caregiving, there's an onset and it doesn't end for years and years, and you still have stressful events that unfold on a daily basis. So really we can look at how does chronic stress shape daily stress processes, what is chronic stress in the moment, and then how can we target that with interventions. So as I said, it's these stress processes of anticipation, reactivity, and then poor recovery. That is the substance of chronic stress that we measure. So I'll tell you briefly about the study that we have been trying to analyze this complex study for years, and we studied 180 parents, mothers of children with autism, mothers of neurotypical children, as well as the dads. One of Eric's grants brought in the fathers. And we really we measured them at different weeks in their life. So over 2 years we measured them for 4 different weeks in their life. And of course we took blood in the middle of the week so that we can look at their rate of cellular aging. And trying to practice what we preach and use the typology. So in this study, as you imagine, we loaded it up with different measures of stress. So we have one of the only measures of chronic cumulative life stress, which is the strain that George Slavich developed when he was here on postdoc with us. Chronic stress or exposure, caregiving. But of course, just being a caregiver doesn't predict much. It's putting yourself in a category, but what meaning are you making of your story? If you've become a parent of a child with autism, how is your narrative of that? So for some people it might be a blessing, they might be religious, they might see it as their fate and their life mission and see the benefits. For other people they might just see it as something that ruined their career and relationship and they reject that experience. So dramatically different narratives from people who are caregivers, who have not chosen this situation. It's come to them. What do they make of it? So I will tell you later about how we're looking at some of that appraisal data. And then of course this daily stress. So when we unpack chronic stress, we ask people when they wake up, are they looking forward to the day? We get their appraisals of both positive expectations as well as negative. At the end of the day, we examine their daily stressor, we objectively rate the severity, and we look at their mood at night and how that changed from their peak response. So of course I have to show this slide because in most of our studies, we stress people out in the lab. We didn't do that in this study, but we use the same framework of threat versus challenge. And it's simply a way to measure both the cognitions and emotions that people are associating with a stressful event. So we can categorize, is someone having a threat appraisal where they're feeling their social self is threatened or their resources, or a challenge appraisal where they're feeling positive about the experience and there's opportunity to gain. And of course, Wendy's been a pioneer in doing this in the lab. You can see that just this snapshot of threat versus challenge predicts reactivity in the moment, and it also predicts telomere length. So it's a trait-like response that we tend to carry around with us. So just think about your morning and when you woke up and ask yourself what were your predominant cognitions, if you remember? How much were you looking forward to events today, dreading them, feeling in control, looking at your phone, at your to-do list, and having a stress response? So worrying, feeling anxious, overwhelmed. So we measure these every morning. And let me just tell you that this is one of the biggest predictors of our cell aging data and our rate of cell aging, waking up responses. Nothing's happened yet. Nothing has happened. And so this shows there is no clean slate. When people are caregivers, they wake up and they have these exaggerated threat responses. So our question really for this SAGE study was whether this caregiving context shapes daily experience, which then explains why caregivers tend to have shorter telomeres and more inflammation. And so that's a predominant model of aging. We call it inflam aging, where there's a slow buildup of inflammation over time. And of course, this leads to different diseases of aging. So how do we really flesh out daily experience from this kind of threat challenge model to summarize how we respond to waking, to stressors, and how much we've recovered at the end of the day? What I'm going to show you is how we've just summarized the data into what we're going to call the chronic stress reactivity syndrome. So we measured threat appraisals, the emotional reactivity, and how people have recovered by the end of the night. And what we find is all of those responses, what we measure when they wake up, what we measure when they go to bed, very highly correlated, very exaggerated in caregivers. And of course, I couldn't give you a talk without showing you this slide of telomeres. So telomeres are these caps at the ends of the chromosomes. They predict one specific pathway of aging. There are many different ways cells age. And so telomeres predict the time that cell, usually we're talking about immune cells, is going to go senescent and be unable to divide. We call it replicative senescence. It happens in the brain, in the hippocampus, it happens in the immune cells. Any proliferating tissue has a limited ability to divide over our lifespan. So telomeres are a very long-term predictor of how long that cell is going to continue to divide. Telomerase is the enzyme that actually can build back telomeres and protect it. So we found acute stress impacts telomerase, chronic stress. So the telomerase enzyme is very dynamic and interesting to us. I'm not going to go into this, but there's a tremendous literature at this point over the past 15 years on mental health and telomeres, and Owen Wolkowitz has been a big contributor to it. Eric and I just spent too much time, watch out, saying yes to an annual review. This guy is the one to, he's an editor on one of the annual reviews. So we reviewed all this. If you're interested in how telomeres are related to mental health, this is just came out, and the bottom line is that it is really transdiagnostic, and there are probably some common RDoC processes of wear and tear, besides of course stress and negative affect, which I'm focusing on, that promote early telomere wear and tear and early cell aging across psychiatric disorders. So in this SAGE study, let me just go to the first question. The a priori question was about inflam aging. So do caregivers, when we just look at group category, very crude, do they have shorter telomeres, lower telomerase, and greater levels of systemic inflammation? When we look at the immune system, certain cells age earlier than others. When you're older, you get a proliferation of senescent CD8 cells. We call them CD8 28-. So they're kind of end of the line. They're no longer fighting infections, they're just pro-inflammatory. In young, healthy people, does chronic stress lead to a buildup of senescent cells? And so we sort cells, and we measure the CD8 28- cells, and we even measure the telomerase activity in those cells. And if they have low telomerase, the inference is they're more aged, their telomeres are going to shorten more quickly. So here's what we find, just from looking at group status, that as predicted, the only difference in telomerase was in the CD8 28- cells, that they were prematurely aged in the caregivers and not in the other cell types. The inflammation was higher in caregivers, but not significantly higher. So what about their daily stress processes, their appraisal, their reactivity? So we plotted that across time on average, and this is a complex slide, but let me just say that the caregivers who are the red lines are higher at waking and bedtime, regardless of if it's a stressful day or almost nothing happened. So we have these non-stressful days where we still make people identify what the most stressful thing is. Maybe it's traffic and rushing. So even on a non-stressful day, you can see these dotted lines that the caregivers start off, they wake up with more anticipation, worry, and stress. They have peak responses and more prolonged thinking about the stressor and worse recovery. So what does that look like if we collapse and we kind of say, okay, across all these different appraisals and reactivity, can we look at a summary of the chronic stress reactivity syndrome and see how it's different on a non-stress day and a stress day? And here's what's so interesting. Controls who are not under chronic stress, they react just as much. The difference between a non-stressful day and a stressful day is just the same, which is great. Wendy likes this, right? Because reactivity is healthy and important, and you don't want to see blunted reactivity. But what's different is that caregivers have a higher baseline. They wake up with a higher baseline even when nothing happens that day. And so they're significantly higher at every point. For a caregiver, their non-stressful day, they are full of appraisals, perseverative cognition, and negative affect, the same level that a non-caregiver is on a stressful day. So their control day, their rest days are the same as stressful days for normal people. They have around 30 more days a year that they have a moderately stressful event in their day when we add it up over time. So does that map onto cell aging? So this is just this is a composite at the top, which is really what I'm showing you, which shows you that the more that you have these chronic stress processes, the lower your telomerase in these age cells, the higher your inflammation. So, and then when we break it down to the different ways people experience stress from waking to bedtime, it's really pretty equivalent across those different ways. It's a syndrome. The alpha is almost 0.9. So really, this is like I don't want to call it a monolithic response, but we feel comfortable summarizing and lumping here because we think it's a syndrome. It's a cluster. It's people wake up and they have a stereotyped way of responding to what unfolds regardless of what happens. So back to that model, I initially said, so do these daily stress responses explain caregiver category? So in these Preacher and Hayes mediational models, this is done with bootstrapping, and I'll just tell you the bottom line here. What we found was that caregivers had lower telomerase, as I showed you, and it was significantly mediated by their daily stress processes. We are so happy to find mediation. If things were more deterministic, it would be a pretty glum story for caregivers. But really the story is there's tremendous variability in caregiver responses during the day. Some controls look like they have the chronic stress response syndrome. Those group differences are just statistically significant, but at an individual level, they're not going to predict much. What matters is the unfolding appraisals and emotion in a day, and that is an intervention target. That is what's malleable. That's what Alexandra Croswell and Steffi Mayer are focusing on with their intervention research. For inflammation, no direct group effect between caregiver status and inflammatory processes. Good. They're young and healthy. They're premenopausal, right? You don't want to see systemic inflammation elevated. But you do get indirect mediation. Caregiver status, of course, this elevated chronic stress response syndrome during the day, across days, and that is what predicts elevated CRP. So, we do think that this is going to be, we can reduce this measurement battery, and one of the exciting things happening at UCSF, it's really nice to have friends who think big. Wendy Mendez has developed a stress app on the Samsung phone. She already has 25,000 people who have this new Galaxy 8 who have filled out their weekly stress patterns. And she's included early trauma, and she's the most generous collaborator. So there's going to be phenomenal opportunities at UCSF to be looking at daily stress at a population level and intervening. Stay tuned. Okay, so you might be wondering about telomeres. They were not shorter in our caregivers. That's good news for caregivers. But we did look, as I showed you, we did look at cumulative lifetime stress. So Steffi Mayer has looked at whether adulthood stress, childhood stress, or the accumulation of them predict rate of telomere shortening over 2 years. And while people have done this cross-sectionally, people haven't looked longitudinally. And there are very, very few studies in the world who have ever tried to catalog lifetime stress exposure. And for something like allostatic load and telomeres, that is the metric that adds up, and that should matter. So using the strain, looking at acute and chronic events as well as perceptions, what she found was that lifetime events, childhood to adulthood, predicted telomere attrition over 2 years, or predicted shorter telomeres when they started and greater rate of losing base pairs over 2 years. But then, of course, she looked further to say what period of life mattered. Was childhood more important? And it was. So it wasn't acute events, it was chronic events. So nothing is surprising here. Chronic adversity during childhood has all sorts of ways of becoming biologically embedded in the brain, in the body, and this is yet another demonstration. First time people have done this prospectively with telomeres. So Eric and I are, of course, interested in all the different ways the cell ages. They're correlated, and we have a very wide battery of different ways of looking at how cells age. So I'm going to just briefly, I've talked to you about what our grant was about, our a priori about inflam aging, but we've also looked at these different ways that cells age. So let me just give you some previews. So with Martin Picard at Columbia, we've been able to look at mitochondrial health, not just like count your mitochondria, which is a really messy measure that doesn't tell you much, because if you have faulty mitochondria, you make more. So it doesn't mean that you're better off if you have more mitochondria. But he actually measured the activity of the mitochondrial enzymes and adjusted it for how many mitochondria the women have. And so no one has ever looked at whether stress can dampen down mitochondria. Mitochondria are these energy these energy factories in each cell that are a critical part of aging. They're best friends with telomeres. When they get old and leaky, they leak electrons or free radicals that damage the telomeres. When telomeres get short, they send signals to the mitochondria. So it's an interdependent system. So in this new measure of mitochondrial health, we use this composite to ask, of course, the first basic question: are caregivers looking like they have worse or dampened mitochondria? There was a significant group difference. It just came out. And we also were able to look at mood at waking and at night. And this helped explain, it significantly mediated this effect. So again, we're back to getting to look at the substrate of chronic stress, which is something we can manipulate. Mood in the morning is particularly important for telomerase. Mood at night and the morning was important for mitochondrial health, but especially at night. And we think of mood at night as recovery from the day. So here you can see that the people with the lowest mitochondrial function had the highest negative mood at night and the lowest positive mood. And the people with great mitochondrial enzymes had really high positive affect at night. regardless of whether they had a child with autism or not. So this is kind of the freedom of looking underneath and saying it's how we respond to a day that matters. And so that gives us the ability to be working with something like mood. So like we manipulate positive mood at waking. So many of you might naturally wake up with a stress response and with worry and rumination, but then you have an opportunity to change that trajectory. There are lots of easy ways to increase positive emotion, like thinking of gratitude, like recalling something you're looking forward to. So these are malleable targets. So we're pretty excited about these bookends effects that we're finding about waking and sleeping. Eric looked at the age of the immune cells. Caregivers have significantly fewer new cells across these immune cell types. The naive cells were significantly lower across the CD4s and the CD8s. Eric also looked at clotho, an enzyme related to cognitive function, significantly lower in the caregivers, and especially if they were older. So looking at age correlations is another interesting way to infer whether there's a wear and tear process. For controls, it doesn't matter how old you are. Clotho is the same from 20 to 50 years old. If you're a caregiver, the more years of life, the lower your clotho, greater wear and tear, greater mileage per year. Rachel Radin is a wonderful postdoc at UCSF who is examining, rather than at the cellular level, really trying to understand how chronic stress is shaping drive for palatable food. So cravings, food addiction, metabolism, and interventions that attack that constellation. So this is important, especially for women under chronic stress. They tend to be obese. We had to shape our study to recruit women who were matched in BMI, because in the population, caregivers are more obese. So we matched on BMI, and yet she still found that the caregiving women as a group had significantly higher levels of HOMA in the pre-diabetic level. So we have caregivers from the community who are healthy and young coming in with prediabetes because of chronic stress. So again, this is another domain related to health, more to health behaviors and diet, and of course she's finding dietary differences that we can target. And so one of the designs that we're working on for one of our next grants, Eric and I, is comparing not just these stress reduction interventions that we know help a little, like mindfulness, but also metformin. And what does that mean when you add metformin to the mix, like the diabetes prevention trial? So lifestyle alone is not going to be enough to change metabolic syndrome. All right, so what's the bottom line in terms of all these cell aging factors? So you can see that most of these factors were more aged or accelerated in caregivers. So I showed you clotho, progenitor cells. Kirsten Oshbacher, who's also in our department, found that the caregivers had significantly lower levels of these important progenitor cells that reshape and protect our cardiovascular lining. Now, appraisals are really important. The story people tell about why they're in this situation in life predicts rate of telomere shortening and inflammation. So let me just say that there's many different ways to measure appraisals. When you step back, I'm talking about meta-appraisals. What does this mean? What does this life mean to you? This is your life. You can't change it. What's the story you tell yourself? So Nico Del Paz has developed with Brian Siegel a scale called the Adjustment to the Diagnosis of Autism Scale. Takes a few minutes, and what we can do is categorize people into, are they having despair and self-blame, or are they having acceptance? And I'll just tell you, acceptance is not something that comes on day one. Acceptance comes with years for most people. So there are not that many people who score that high on accepting that this is their life. And what Nico found was that those parents who did had less depression when they came in, but it protected them from depression over the few years. Whereas the self-despair and blame impaired their relationship, their quality of life. So this is important. It could be used clinically as a screener just to target these couples who are really at high risk of both their own poor mental health and quality of life, but of course that affects the treatment as well, because the behavioral treatments involve and require parental engagement. Ashley Mason and Kirsten Oshbacher and I have been also looking at self-identity codes that can come out of these parenting narratives. So when you ask someone, tell me about, a stressful experience of parenting and how it's affected your life, we can code these from looking at whether people are making meaning of the story, whether their story is integrated with their own identity, with their self. And so these integrated stories, this code for integration and meaning making is actually a predictor of less stress, of course, but also less cellular aging over time. So I won't give you the details on that, but one of them hopefully tell the fuller story. Lastly, I wanted to talk to you about mind wandering. So during this talk, you have mind wandered maybe half the time, unless I've been really successful keeping your attention. And that's natural. Mind wandering predicts unhappiness. And really, it's not just mind wandering, it's the quality of mind wandering. So Alexandra Croswell has been examining on a daily basis what happened in your day and how has it affected the presence of your engagement, your attention at night when you're at home at the end of your day. And this has been very interesting. And I'll tell you that I believe that this state of mind of assessing how present and engaged you are in whatever you're doing is happiness, is quality of life. And the opposite, feeling that you don't want to be where you are, feeling that you wish you were somewhere else, you wish you were doing something else, is suffering, is unhappiness, is a very poor quality of life. And so we assess these and we think they're very important, and again, intervention target. So what she's found is that for everyone, whether you're a caregiver or not, when you have a pretty stressful event that day, it knocks your mind state at night into more of a negative rejection state, rejecting your current experience. So you can see that on when people had stressful events that day, so this is an intra-individual daily diary study, so this is per person, whatever their baseline and average is, if they've had a big event, they're more rejecting of their experience at night, less present, but especially if you're a caregiver. So there's an interaction with group, especially for this kind of, we call it dissatisfied with your moment, but rejection of your current experience. And she's also found some biomarker correlations, and I'll let her tell that story a different time. So that brings us to intervention. And one of the things that we know is we're not going to change the waves that are coming. We're only going to change how people respond to them. And that is the only thing we can control is our response. So, well, there are some stressors we can weed out. But the interventions that change how we relate to our thoughts have been very effective for rumination, like, for example, mindfulness-based cognitive therapy. One of the key ingredients is actually reduction in rumination through developing metacognition. And so when you ask people who take this kind of popular MBSR class, what did they get out of it? They learned a bunch of skills, right? It's a kitchen sink. My thoughts are not myself. That's what it comes down to. So people develop a perspective they can take with them, whether they're meditating every morning or not. So that's a key component of these contemplative interventions. There are many proof of concept trials, particularly with meditation, mindfulness, but with any mind-body therapy, we don't think it's very specific, showing that you can slow the rate of cellular aging so that telomeres and telomerase can be boosted with meditation, or the rate of telomere shortening can be slowed. So we just had a paper come out this month led by Cliff Sarin at UC Davis and Quinn Conklin that looked at an intensive 3-week retreat at Spirit Rock. I recommend you check it out. It's down the road across the bridge. But it's if you want change, you want a retreat. We never see as much change in people as we do when people go away in a safe area. They feel safe, they're learning a skill. So we've been studying these retreats from a week to a month. So in this study that's now online, we found that that telomere length lengthened over 3 weeks, and that the genes for telomere length also were overexpressed. So of course it's just a pilot, and we don't know if these changes maintain. So it's just a step. All right, so I'm at the end here. I'm just going to point out that what doesn't kill us can make us stronger, and that is the attitude for us to take with us as we approach things, unpredictable but particularly predictable, and as well as through intervention. So this idea of positive stress is really something we're really excited about. And let me just tell you, this is, a view, whether it's psychophysiology or mood, that resilience to stress looks like this. It's this blue line, which is low baseline, big strong peak response, and quick recovery. So health is not about lowering arousal and avoiding stress and being soft and mushy. It's about engaging in a robust way and recovering quickly. That is what promotes, that's what slows cellular aging and of course promotes resilience to stress and depression. So we already know this through all these worm studies and lower species studies that hormesis or short-term stress is toughening and is cleaning out cells and promoting better aging. But what about in humans? Like, what options do we have for promoting positive stress? Exercise, right? So there's not much in this basket here. So we really need to think about how do we promote positive stress. There are interventions that can do this psychologically with training, like Wendy's reappraisal intervention. There are interventions that can do this physiologically. We're now looking at high-intensity interval training, because it's these bursts that people recover from. This should theoretically promote more of these anti-aging mechanisms. So the study that Eric, Wendy, and I are about to start, many of us here at Steffi Alexandra, is a study of extreme breathing. And so we already know, well, how much can you control your autonomic nervous system? It's autonomic, right? Can't control it. That's what the textbooks say. So of course that's not true. Exercise can change it a bit. One of the things documented in a couple studies decades ago is that there's a way to do extreme breathing called tumo breathing that monks do that can raise your body temperature to 8 degrees. And so can we use that? There is someone named Wim Hof who is all over the web, so you can look at what he's doing, but he's using that and putting his body in ice and withstanding ice for 2 hours, and he's won like 24 world records for controlling his autonomic nervous system and increasing his body temperature so his kidneys don't get burned. For any of us, within a few minutes, we would be having problems. So this method, which is close to tumo breathing and what the monks have done that's published in Science, he's just taken it and kind of stripped it and down to basically hyperventilation and hypoxia and the cycles of it. There's a paper in PNES showing that this improves the immune response to endotoxin. And of course, in our hands, we want to know, is it improving stress resilience, challenge reactivity, and changing the rate of cellular aging. So we just got a donor grant. We're super excited to be studying all these different positive stress interventions and comparing them. So in conclusion, I will just end with thinking again about the waves and how we can surf them and not fall under them, especially when it's a big one, with what we know about how we respond to positive stress, both ourselves and for our different people we're trying to help. And I want to acknowledge all the wonderful people I work with. And I'll end there. Let's see, we have 2 minutes for questions.
Scheduled to stay beyond 9, so please, questions for Elissa.
Have you looked at all at how some of your measures relate to the concept of biological aging, in the geriatric literature at least, that has been interested in the difference between your age and biological aging, defined essentially, as I can tell, by sort of cumulative measures of illness, A1C levels, various things. And it strikes me that it is sort of interesting because once you have those factors of biological age, they're less reversible than the things you're talking about, even though the measures you're looking at are clearly upstream. And if you did look at it, it strikes me that it would be easier than looking at mortality, which I guess is easy to measure, but you wait a long time.
That's right.
For your
Yeah.
outcome.
Yeah. So great question. So the question is, what about kind of clinical markers of dysregulation in early disease, like HbA1c? And so these develop. Well, typically these have developed later in life. Now we see them developing in kids with the obesity epidemic. But we think of those as allostatic load. So it's the creep up of the dysregulation of our different biological systems, immune, metabolic, adiposity, lipids. We can measure these, and they predict later disease and mortality. So this allostatic load measure is what across the different systems, how dysregulated are you? You have no disease, but you have a level of dysregulation. So that is, I think, very similar to what you're talking about when we think of clinical biological aging. And I agree with you that those are harder to change once they develop, and they are usually later in life. So the beauty of these cellular measures is that, well, number one, they do predict all these risk factors, and they do predict mortality, many of them. So we think that they're relevant and important, but we can try to move them around with short-term interventions and not wait till people die. And this whole idea of looking at decline and aging and stress, it's a very static field with static models. And what we really know is that we can only really assess health in a dynamic way. So like that graph of health, positive health, is not just this low baseline. You want to have low baseline when you're safe and when you're sleeping. You don't want to have vigilance, but then you want a big stress response and a big recovery. And so by looking at both autonomic and cellular aging responses and neuroendocrine responses, we think these are those really upstream markers that are going to determine the clinical markers, and we want to manipulate them in short-term interventions and see how we do. So that's the quick answer. It's much more satisfying than waiting till people die. But the other thing is, in these large studies, when you wait till people die, you're only measuring static things like self-report measures and clinical risk factors. So one of the examples of why it's about positive stress and not baseline is, for example, heart rate. So, it goes up a little bit with age, it predicts a little bit of mortality, but if you look at heart rate after you exercise, that is a much bigger predictor. And when you look at aging, that's where the defect is. It's the recovery. So older people have much slower heart rate recovery after exercise. And that's just one example of a system where we want to probe it. Yes?
So you mentioned
Christine, nice to see you. You're so far away, Mike.
you mentioned when you wake up that your state when you wake up is so critical, but you didn't really talk much about sleep. And I know you're involved, Eric, and the group is doing a lot with sleep. Could you talk a little bit about how sleep quality could also, because that you spend so much time in sleep.
Yeah.
And obviously the nature of that sleep, how restorative it is versus not.
Right. So so it's a great question. What's the role of sleep? Because if we're really talking about things that are restorative, that's it. That's the biggest thing we can do, right? So we know that duration matters, and when we look at these cell aging measures like telomeres, we also know how important quality is. And quality is something that we influence on a daily basis by whatever we do before we go to sleep. And so, there are the obvious things like, did you exercise? Did you have caffeine? But I strongly believe that there is a ramp down that most of us are missing that can actually change the quality and the physiology of our sleep. So rather than like the Hong Kong airport, it's kind of this like crash landing for those of you who have been there. You can still land safely, but it's like this huge dip. And then you're there. Whereas if you think of sleep as you want to ramp down slowly and have it be a sacred period where you're not having screens and you're not thinking about work, you are changing your allostasis, your physiology, your level of perseverative cognition, and that is going to impact the quality of your sleep. So I think there's a big missed opportunity there because it's invisible and we don't necessarily feel the effects with influencing sleep quality, not just quantity. So Eric has done most of the telomere sleep studies, and so there certainly are important relationships with a lot of these biomarkers of aging, including epigenetic clock and inflammation and telomere length, with quality and quantity of sleep. And it looks like the cutoff is if you're getting less than 6 hours when you're older, you have significantly shorter telomeres. And I don't know about you guys, but I have been really dismayed by, unfortunately, we're doing a study using Fitbit, and the new Ionic tells you how much you've slept based on your sleep stages. And so, I get at least an hour less a night than I thought, like when you actually look. So, knowing that, measuring that just as an assessment, and then adjusting your sleep time, I think is hugely critical and informative. One more. Yes?
What is the current literature evidence on children and using these kind of biological measures like the telomerase and the impact on cognition, cognitive processes?
So there's been,
Can you repeat it?
so the question is, are these cell aging measures used in children? And there hasn't been much with cognitive measures in children, but I believe that the most important and interesting studies now are about pregnancy and early life, because the trajectory, and like Nikki Bush's study where she's following a cohort of children and measuring their telomere length attrition, knowing everything about their pregnancy and their mom. So really what we know is that where you start in life is the biggest predictor of what your telomere length is when you die. And so this now, I would say, convergent findings across different cohorts in different countries that maternal experience of stress predicts cord blood telomere length is very alarming. And there's obviously, there's a genetic transmission, but there is epigenetic transmission. So there's direct transmission of telomere length from germline to offspring. So if you have a parent who has had, let's just say, excessive trauma, chronic stress reactivity syndrome for years, they're going to they may transmit shorter telomere length to their offspring. So the idea of pregnancy interventions and preventing early life adversity or trying to mitigate it are I think critical for these aging processes that track throughout life. Inflammation is another. Steve.
So I hope this is wrong, but if I were being a critic, another kind of take on childhood, are a lot of those measures in your central model that was in the annual review related to kind of a core neuroticism, pessimism, not engaging in good habits from an early age. In other words, could you go back to trait measures and get just as good prediction as you might from all these supposedly, we hope, more malleable measures of daily processes? Mm-hmm. So if I were a trait psychologist and a critic, I'd say most of that variance is tied up in these core traits, some of which are malleable and some of which are less so. How would you respond?
I love that question, and I've been a trait measuring psychologist for many years, and it's been, in studying adults, it's been pretty disappointing. And I think when we think of, the short answer is I don't know, and we absolutely need to measure both. We need to measure, personal strengths and personality and resources, as well as stressor exposures. And then I really believe the unfolding day is going to be very important for an individual to know about themselves clinically and for us to intervene. And some people, we're not all ruminators. We have really different processes. So the idea that what do we know about what predicts healthy aging? So when we think about subjective well-being, there are some things we can ask with a few items that are really important. Purpose in life, life satisfaction. And then there are some things like affective experience that you can only measure with experience. So, the balance of positive and negative emotions, we're not going to get far with a PANIS, but actually when you go into the day and you measure experience in the moment, that is much more predictive. So this is like Kahneman and Arthur Stone, and they've had these huge population-based data sets. And so there is a critical difference between measuring what people believe about themselves in terms of their affect, and of course measuring the momentary experience or just the daily experience. And then, in terms of these systems, I've been, focusing on the negative affect valence system, but there's all these other relationships that show you how the path to telomere attrition is not specific. It's, you know, it's many to many when we think about cell aging, and here when we just look at telomeres, there's multiple interrelated predictors across systems that are related to psychopathology. Thank you for that good question. Thanks everyone for your attention and good questions.
I just want to say, as people depart, Elissa's here as part of the Bay Area lecture series, but being in the Bay Area myself and having traveled to give a similar talk across the Bay Bridge, I think Elissa's talk should be considered part of the Distinguished Visiting Lecture Series. And thanks, Elissa, for a great presentation.